In this video, I'm going to be talking a little bit about testing of materials from the engineering HSC course, Engineering Studies. This is for Year 12, and this is part of Chapter 2, which is Transport. Now, I have talked a long time about testing materials. I try to put all of my testing materials in one go, and I pretty much cover all of the testing in Year 11, so that way I just have to revise things. That said, I do have an audio recording where I talk a lot about testing materials, and we'll have a look at my notes. So the first thing is we need to know is there's 4 different hardness tests. So without looking at the book and just looking at my notes, the different hardness tests, let's have a look if I can find my hardness tests. Okay, so the first one is thin metals. The thin metals is we want to worry about is the, what do we use for thin metals? For the cat food tin?
Oh, Vickers.
Vickers, excellent. I'm so pleased to hear you all say that. Vickers is definitely the answer here, overrepresented. Hardness tests here. There are multiple hardness tests. We have a Rockwell hardness tester, right? That's the one here, just there. It is the most commonly used. It's the reference point that most will refer to. When I asked Sam Rockwell how hard he thought he was, that was the one I was referring to. Obviously, I mean, it was Sam Rockwell. So anyway, I wasn't talking to Mr. Vickers. Vickers is used for thin metals, and Brunel is used for, it has a ball, and it's, I like to think it's ball from the before time, and it's bad because it leaves a big bad dent. Okay, or a big bad blemish to help maintain that B alliteration. There's also the Shaw hardness test, which is portable. Now, way back when you guys started in Year 11, we saw someone posted a thing about chocolate harder than steel, and they were using a Shaw durometer. Now, in a video that I recorded over the holidays, like as in over the Christmas holidays, I went into huge detail where I talked about the different kinds of, they use different indenters. So there's a cone, Brunel is obviously a ball, and there's a diamond shaped or pyramid shape, different kinds of things. In that same video, I found like comparative strengths. I went into a little bit of detail about the hardness of chocolate. We talked about the Mohs hardness scale, which is spelled M-O-H-S, Mohs hardness scale. But the fact is, if you can identify those 4, I'm happy, right? If I said which one uses a ball, which one leaves an indent, which one is a destructive test, you'd say, oh, that's Brunel, because from the before time, right? So not a very good one. Rockwell is the mainstream one, right? Vickers is used for thin metals, and the Shaw is portable. Right? You can carry it around. You can take it to the Shaw, exactly right. It's also called the Shaw scleroscope or the Shaw durometer. It looks a bit like a stopwatch, and you just hold it against the object, and it will register. Okay. So that's our first set of tests. The next set of tests, I've got to find the book, there we go, is impact tests. So what are impact tests? Impact tests, what do they test? Great. What's another word that we use? What property, what material property do we test? Not toughness. Okay. They determine notch toughness technically, but they're a good measure of how much impact something can take before they break. The example I like to use is if you drop your phone on concrete, if it scratches, it means it wasn't very hard. If the glass shatters, it means it wasn't very tough. So there are 2 different properties that we're interested in. What is unfortunate is generally as things get harder, they usually are less tough, and vice versa. So for things that aren't very hard, we call them soft. For things that aren't very tough, we tend to call them brittle, right? Yes?
Is there anything that's really tough and really hard?
Yeah, well, I mean, like, so for instance, tempered steel, it has very, very good hardness and reasonable toughness. That would be, and even if you talked about annealed steel, we'd still say annealed steel has still pretty good strength, right? Relatively good strength, but is incredible toughness. So that's sort of an example there, whereas everything sort of fits into some sort of, and in terms of Gorilla Glass, if you compare it to regular plate glass, right, amazing hardness, amazing toughness, right? Both of those, on both axes, it's drastically improved. Okay, so what I have here is I have a video of a impact test, This is from way back when we did a video on grain structures, but I like it and I use this video for lots of things. So we see that when what test are we using here? The specimen is standing and the notch is facing the hammer. Izod. Izod, right? Like General Zod, he stands and he fights, right? He faces that hammer. I have no idea which window it is. Third one? God, thanks. That could have taken long. Okay, Sharpie on the other hand, Sharpie was a French engineer, and it helps me remember that Sharpie lays down and faces away, right? French Sharpie looks away from the hammer because he's afraid, right? Whereas Izod, listening to his iPod, he is not afraid, right? That's how I remember that test. Okay, so moving on to our next. We're now onto heat treatment of metals. Now, I appreciate that we're coming up onto the bell very soon, but I have just recorded for Year 11s a very extensive summary of heat treatment. Over the holidays, I also did a very extensive recording on heat treatment where I talked about even beyond the Year 11 course. The things that I want to draw your attention to. You should all by now know annealing, normalizing, and quenching and tempering, right? You should all be familiar with that. A little bonus that you need to know is you need to know for Year 12, you need to know process annealing. And I like to remember that process annealing protects the pearlite perfectly. Yeah? So process annealing protects the pearlite. It doesn't affect the pearlite. It only affects the ferrite. Yeah? Only the fickle ferrite is affected. Yeah? Okay. In terms of hardening, it's important to remember that in addition to just quenching, we can also air harden, right? Which is, if we use a molybdenum alloy, we can air harden. We can also use hardening process. So there's something called Bainite. I'm not going to go into detail on Bainite in this course here, but I'll say that students who are expecting to do well, they should study Bainite and be familiar with what Bainite is. But what we're going to look at is surface hardenings. So there's case hardening. Case hardening uses what element? Starts with the same letter? Carbon. Okay, case hardening is where we add additional carbon atoms into the iron lattice. I used this example in the last recording. Imagine if you went to the grocery store and you saw all those apples. Imagine those apples are your iron atoms, and you just were squeezing grapes in between. If you squeeze those grapes in between, it's going to make it harder to shift all of those apples, and that makes it harder and stronger. Okay, nitriding, same idea, except this time we don't use carbon, we use, and the advantage is something resistance, starts with C, corrosion resistance. The downside is, at 500 degrees, it loses all of those properties, it all disappears. We also have flame hardening. Flame hardening uses a flame holder and a water jet. And what that does is it gives you the equivalent of quenching, but just on the outside. There's induction hardening, which uses electricity. The advantage is that it can be automated. So if you're going to harden just the outside of something, like gears, you just want to harden the outside of gears. You want them soft on the inside and hard on the outside so they don't wear away. And that would be a great application for induction hardening because it can be automated. Now, hardening. Okay, in the video I just recorded with Year 11s, we talked a lot about samurai swords. Samurai swords, they're only partially quenched because they have that same thing, that they want to be soft on the back so they don't snap, but hard on the front so they can be sharp. Now, the next thing we're going to look at is we're going to look at manufacturing techniques. This is exactly the same as what we did in Year 11 with a couple of differences. We're going to look at the difference between hot and cold rolling, and we're going to learn a lot about casting. I have made a very long video on casting, and I expect you to watch that video rather than me talking about here. We're also going to speak about, after casting, we're also going to look at impact and direct extrusion and powder forming. So we will look at that next lesson.